The solar system, our home in the cosmos, is just a tiny enclave in the spiraling Milky Way. 8 planets, countless moons, asteroids, and icy wanderers all orbit an average yellow star we call the Sun. At first glance, it might seem like these worlds follow their own separate paths through space, but look closely and you'll notice something remarkable. They're almost all moving within the same enormous, invisible sheet, a kind of cosmic racetrack. This arrangement is no accident. Billions of years ago, a swirling cloud of gas and dust collapsed under gravity's pull, giving birth to the Sun and its planets. The leftover materials flattened into a rotating disk, and from this disk emerged the neat, aligned orbits we see today. Think of it as a massive vinyl record floating in space, with the planets as the grooves. The disk is roughly aligned with the Sun's equator, but roughly is the key word here. Not every world in our solar system obeys perfect symmetry. Mercury's orbit leans about 7 degrees compared to the main plane. Pluto, demoted to dwarf planet status, is far more rebellious, tilting nearly 17 degrees. And comets, they're the wild cards of the solar system. Many don't just tilt. They come in at steep, plunging angles, slicing across the planetary plane almost vertically, like darts cutting through a spinning frisbee. Here on Earth, up means sky and down means ground, thanks to gravity's constant pull toward the planet's center. But step off the Earth into space, and those words lose their meaning. There's no universal north, no galactic ceiling or floor. 2 astronauts floating side by side might appear upside down to each other, yet both would be correct from their own viewpoint. When scientists talk about above and below the solar system, they're speaking relative to the ecliptic plane, that flat sheet formed by the planet's orbits. This imaginary reference gives us a way to discuss direction in a place where orientation is entirely a matter of perspective. If we start venturing away from this ecliptic plane, the first major structure we encounter isn't flat at all. It's round. In fact, it's one of the most mysterious and least explored parts of our solar system, the Oort Cloud. The Oort Cloud isn't a disk like the planet's orbits. It's a vast, spherical shell surrounding the entire solar system. It's so large that its outer edge could lie as far as 100,000 astronomical units from the Sun, a quarter of the way to the nearest star, Proxima Centauri. Inside this shell lurk trillions of icy objects, mostly made of water ice, methane, and ammonia. They're leftovers from the chaotic days of the solar system's birth. Giant planets like Jupiter and Saturn acted as gravitational slingshots, flinging countless icy chunks into distant exile. Some were lost to interstellar space, but others remained trapped in huge elliptical orbits that form the Oort Cloud today. We've never photographed it directly. Its existence is inferred from the paths of long-period comets, which take thousands or even millions of years to swing around the Sun. These comets approach from all directions, not just along the planetary plane, exactly what we'd expect from a surrounding spherical cloud. Beyond the planets and overlapping with the inner Oort Cloud lies another colossal structure, the Heliosphere. This bubble is carved out by the solar wind, a constant flow of charged particles streaming from the Sun in every direction. The heliosphere acts as a protective shield, pushing back against the interstellar medium, the thin soup of gas, dust, and charged particles that fills the space between stars. But the heliosphere isn't a perfect sphere. It's stretched and distorted, shaped by the solar system's motion through the galaxy. Imagine a boat plowing through the water. A bow wave forms at the front, while a trailing wake stretches behind. The same thing happens here. The heliosphere is compressed in the direction of our motion and extended behind us. The outer boundary, where the solar wind slows to a crawl and mingles with interstellar space, is called the heliopause. Beyond it lies true interstellar space, a realm that is far from empty. Even outside the heliopause, we're still moving through a defined region, the local interstellar cloud. This is a slightly denser patch of interstellar material that our solar system is currently traveling through. And we are moving fast. The sun speeds around the Milky Way at roughly 828 kilometers per hour. On its journey, the solar system passes through various regions, some thick with gas and dust, others more like cosmic deserts. The local cloud is just one stop in a journey that will continue for millions of years. Zooming out further, we find the solar system sitting inside an even larger feature, the local bubble. This is a vast, 300 light-year wide cavity in the Milky Way's interstellar medium. The local bubble is unusually empty, with far less matter than the galactic average. Astronomers believe it was hollowed out by a chain of supernovae explosions millions of years ago. These massive blasts swept away the surrounding gas and dust, leaving behind a thin, irregular wall of denser material around the edges. Think of it like living inside a huge room with walls made of cosmic fog, beyond which lie more clouds, more bubbles, and more mysteries. All these layers, planetary plane, the Oort Cloud, the heliosphere, the local cloud, and the local bubble, are not fixed. The solar system is constantly moving, like a ship in a restless ocean, pushing through waves of interstellar material, bumping into boundaries shaped by ancient cataclysms, and entering new regions of the galaxy. From above and below the ecliptic, our home is far from flat and simple. It's embedded in a constantly shifting three-dimensional cosmic web. Understanding this vertical dimension of our solar system helps scientists see where we fit in the galaxy. By studying how stars and gas move relative to the galactic plane, astronomers can piece together the history of the Milky Way, when and where stars formed, how supernovae reshape the galaxy, and even how dark matter is distributed. And just like the solar system, the Milky Way itself isn't perfectly flat. The Milky Way itself is perfectly flat. Its disk is slightly warped with spiral arms curling outward and a central bulge at its core. Surrounding it all is the galactic halo, a vast, spherical region filled with ancient stars, star clusters, and quite possibly huge amounts of invisible dark matter. Most people picture the solar system as a flat diagram. Planets neatly line up in a row, isolated from anything else. But the reality is a far richer, more layered, and more chaotic environment. Above and below the planetary plane are ancient ice fields, magnetic boundaries, drifting interstellar clouds, and enormous voids carved out by dead stars. We are, quite literally, sailing through a complex and ever-changing cosmic landscape. And yet, in the midst of this vast, often violent universe, life appeared and thrived on a fragile blue sphere orbiting a modest star. That, perhaps, is the greatest wonder of all. So next time you gaze at the night sky, remember, we're not just circling the sun. We're taking part in a grand galactic ballet, spinning, drifting, and weaving through a universe where up and down are just ideas, and every direction hides something new to discover. What amazed you most? The idea of a spherical Oort cloud stretching almost halfway to the nearest star? The solar wind's invisible shield? Or the vast local bubble left behind by long-dead suns? Share your thoughts below, and if you love exploring the wonders above, below, and beyond, don't forget to like, subscribe, and join us for the next journey into the cosmos.